For this example, you're going to imagine yourself as an environmental chemist. And what you're going to imagine yourself doing is analyzing some waste from an industrial process that produces very hazardous compounds like carbon tetrachloride and benzoic acid. We're going to focus this analysis on benzoic acid, which is a weak acid that has one acidic hydrogen. So this waste that you analyze has a mass of 0.3518 grams, and you mix it with water, and the solution then that you get when you mix it with water is neutralized with sodium hydroxide, and it takes 10.59 milliliters of a 0.1546 molar solution to completely neutralize the sample. What you have to do is calculate the mass percent of benzoic acid in the waste from that process. Now you have the entire problem written out on your page, but on the board I just wanted to put a simple overview. So again, this is like a real world application. If you were an environmental chemist, this is what your job would be. So the objective of this problem is to find the mass percent of benzoic acid, which is HC7H5O2. This from the C7H5O2, that's benzoate. When you add that H, that makes it benzoic acid. So we have to figure out what the mass percent of benzoic acid is in the original sample. Now, what do we know from the problem? Well, we know the mass of the sample, and we know the volume and concentration of sodium hydroxide that was required to neutralize. So let's say you have no idea where to start. Work it out like a stoichiometry problem. What are the steps that you would go through? Well, what would be the very first thing that you would do? Hopefully you say it would be to write a reaction. So the reaction for this example is the benzoic acid, which is aqueous because it's an acid, plus OH minus, which is aqueous, yields water, and the benzoate ion. Now, where's the sodium in this? What happened to the sodium? Well, it was a spectator ion. So the Na plus on the left, the Na plus on the right, I just canceled out and I wrote the net ionic equation. Now you may be like, whoa, Miss Carney, what's happening? This is an acid. Why isn't it breaking down? Well, it's a weak acid. Weak acids do not dissociate very much at all in water. So we actually are going to leave it as the molecule just with AQ after. That shows me, and that should show you, that that's the weak acid, so it's not going to break down. So we have benzoic acid plus the hydroxide ion makes water and the benzoate ion. Again, this is the net ionic equation, and this is showing the neutralization. Now, we've done enough neutralization reactions that hopefully you know where to start. The first question I would ask myself is, how many moles of hydroxide are used in the neutralization? Right, this is the same as figuring out how much sodium hydroxide, but we're just going to include the hydroxide ion now. So how many moles of hydroxide are used in the neutralization? That needs to be the first thing that we figure out. So we're going to use some stoichiometry. Start with given volume of sodium hydroxide, convert milliliters to liters, and then go from liters to moles using the concentration. So we went through the stoichiometry until we got to moles of sodium hydroxide, which, remember, sodium hydroxide to just the hydroxide ion is a 1-to-1. So that means that we use 0.0016372 moles of hydroxide in the neutralization process. Now the neutralization, when it's complete neutralization, that indicates that we need equal moles of acid and base. So since the acid and base, okay, the benzoic acid and the hydroxide, since those react in a 1-to-1 ratio, that means that we need 0.0016372 moles of benzoic acid to make this a complete neutralization. So now we have moles of acid. Now the problem is asking us to find the mass percent, which means once we have moles, we're probably going to have to go to grams. So I have moles of benzoic acid. I need to get to grams, so I use the molar mass. Now, that gets me 0.1999 grams of benzoic acid in the sample. Okay, that's how much we neutralized. That's all of the benzoic acid that was in the sample. So, what percent is this then? Well, I'm going to take the mass of benzoic acid that was neutralized. That's all the benzoic acid that was in the sample. So I'm going to take the benzoic acid mass, divide it by the mass of the original sample. Okay, the original sample, the waste from that process, isn't all benzoic acid. It's just part benzoic acid. So I take the mass of the part, which is the benzoic acid, divided by the mass of the whole, which is the entire sample, and I multiply it by 100 because I'm trying to figure out percent. We find that that's 56.82%. All of our given values were in 4 significant figures, so my answer should also be in 4 significant figures. Now, my answer is 56.82%. Now, I want you to double check. Get it? Double check. Double check. The percent is less than 100, right? So this answer, it makes sense. If your answer was over 100%, your calculation probably got off somewhere. But since this answer is less than 100%, we know that it's probably right. So again, the answer is 56.82% benzoic acid in the overall sample.